Hello everyone. My name is Mohammad Sarmat and currently I'm a student of Chulalongkorn University in the Department of Electrical Engineering. Today the topic of the presentation that we are going to discuss is a low cost and reliable home energy management system using generalized reduced gradient nonlinear solver method. So in the content what we are going to discuss in this video, that we will introduce that what is the actual problem and how we can solve it. We will discuss a factor which is load factor. It's a parameter in energy systems and the objective function that we need to optimize to get the desired results. We will discuss the methodology, that with which method we will discuss and we will optimize this objective function. And in the end, we will find out the results of our methodology and discuss on those results. So the first question is what load factor is and why it is important. Load factor is a parameter through which we can discuss and we can find out that how optimal our system is running. It provides us the efficiency of a system that needs to be discussed during the energy system management. What is energy management system? It is a system that need at the hour that we gonna need, how we can use our energy efficiently. What are the purposes? What are the methods? What are the techniques? There are a lot of them, but in this lecture, we are just going to focus on home energy management system. Smart home energy management system, it is a controlling load that we have different loads in our home that we are going to run at different hours of the day, and we have to run them in an optimal way. So our main component of this problem is a load factor or a load curve. What is a load factor? So the load factor is defined as the average load occurring at a specific time divided by the peak load at the specific time. So it is also the measure of utilization rate, that how our energy is utilized. Means if we are generating a power at one station, we are supplying it to a home. If a home is utilizing it in a perfect way, so our load factor would be a good one, more one. But if it is not utilizing in a better way and it is overlapping at one stage and free at the other stage, so it will be a bad load factor, which is harmful for our system. So we need to make it better by different techniques, and one of them technique we will discuss in this lecture. So the load factor formula is the average load at 24 hours divided by the peak load for 24 hours. This is the load factor for one day. Okay, we can have a load factor at different points at different hours, but this is a formula for 24 hours. How we can calculate a load factor? We will divide the average load divided by the peak load. As you can see in this picture, that there is a horizontal graph which is showing our load, and the time is from 12 midnight to the 12 in the morning. So 24-hour load curve, it shows that at which instant how much megawatt of energy is being consumed, and this also shows what is a load factor, a basic idea of what load factor is. So the objective function, the idea that we have in the previous slide, that what is a load factor? Load factor is defined as the maximum load divided by the peak load, or the peak load divided by the maximum load. So this is the representation of an objective function that we discuss the power demand of a specific load type. The N in this equation shows the total number of load types. J represent the total number of time intervals of the day, and K will show the time interval of maximum demand at any load types. So this is a load factor objective function that we need to optimize. As I discussed before, that more the load factor is, more close to 1, it is a better system that is utilizing a better energy. So what is going to be the methodology? In the first phase, we will find out that what are the types of loads. Either it is shiftable, non-shiftable, or it is partial shiftable. Then we will go to a phase 2, in which we will schedule the load profile that according to our customer, how and when they want to generate energy or to consume energy for those loads. In the third phase, we will apply our objective function with the specific optimization technique, and then we will find out another schedule which will be the optimal one, better than the first one that we have got from our consumers. So this is going to be the method that we are going to use to optimize this objective function, which is generalized reduced gradient nonlinear solver method. The reason to use it is that because it can find a locally optimal solution to any reasonable well-scaled and non-convex models. Best for nonlinear problems. It is a nonlinear problem as well. So we use it because it is perfect for solving nonlinear problems. It have a quality that it can handle both equality and non-equality or inequality constraints. It split the variable in two categories, dependent and independent. And I have told you before that we will have different loads which will be shiftable and non-shiftable. So that's why generalized reduced gradient non-solver nonlinear solver method is the perfect for this situation. So a load profile of a residential building. We have a residential building in which we have different loads, as you can see. Some of them is fully shiftable loads, which are dishwasher, washing machine, and cloth dryer. Some are partially shiftable. These are iron, vacuum cleaner, oven, hair dryer, toaster, electric kettle, TV, and air conditioner. But three of them are non-shiftable, that they have to be used at these specific times. They are non-shiftable. We cannot do any scheduling for that. So these are fridge, indoor lighting, and outdoor lighting. So the main thing for us is that we have two categories, fully shiftable and partially shiftable. We can play with them and we can create an optimal solution. But for the non-time shiftable procedure, we cannot do anything with them. Okay, so as you can see that we have different hours of the day, one first hour, second hour, 3 up to 24 hours for a specific day. So here are the shiftable loads, which are iron, vacuum cleaner, oven, hair dryer, toaster, electric kettle, TV, and air conditioner. Similarly, we have the other loads, which are dishwasher, washing machine, and clothes dryers. These are fully shiftable, so we can shift at any 24 hours. But in these one, we have a specific constraint that they can be only operate in specific hours. As we can see in the previous slide, that a dishwasher have an operational time from 1 to 24 hours. At any time of the day, we can use it. It has to be operated for 120 minutes, which is 2 hours. Similarly, but in partially time shiftable, if like we have iron, we can only shift it between the 4 p.m. to the 10 p.m. and it have to operate for 60 minutes, which is 1 hour. Similarly, a vacuum cleaner can be operated between 9 p.m. to 1 p.m., 9 a.m. to 1 p.m. And this can be operated for just 2 hours, which is 120 minutes. So just like this, we have created this schedule by ourselves using Microsoft Excel, or you can use any simulator or any technique to use it. But at the end of the day, you can see that it will operate for 60 minutes as discussed before. The second one will operate for 2 hours, 2 hours, 1 hour, 1 hour, and similarly, it will take it up to the end. So the base load is have been taken that what is the base load? This is the category which shows that which load is at which instant. And at the every hour, we have a maximum load. We will discuss it later, but to be like familiar with the procedure, these are the load curves values that how much watt of our system is being utilized at which hour. So at the first hour of the day, we are consuming 5,350 watts, which is around 5.3 megawatts. So using a simulator, any simulator, you can draw the graph of our 24-hour load curve. As you can see that at the first hour, we have around 5,000 something. In the previous slide, we showed that 5,350 is the power at the first hour of the day, as you can see. Then it reduces up till like 500 or something, 200. then it goes up again. It is the maximum point at which our load is being consumed. From the system, we can see that it is the 6th hour of the day that 5,750 watts of the energy is being utilized. So after that, after 1 or 2 hours, it goes very down and then it goes up. So it is also the representation of that load curves, as you can see, 5,300 something, and then goes down at the minimum value, then it goes to the maximum value. So these are the main factors that is going to be important for our solution. A load factor is calculated, which is around 0.26. Maximum demand is at 5,750 watts. The average demand, it is 1,543.75 watts, which remain constant. We cannot change this one. And the unit which are being consumed is 37,050 units. It will remain the same. So the last two parameters going to remain the same. We have to optimize this load factor by considering these higher and lower values. The variation between higher and lower values is too much, which is not good for our system. So the load factor is the measurement of the utilization, that how we are using our or utilizing our system. So 0.26 means that we are not utilizing our system in a proper and optimal way. So what we're gonna do, we will apply our optimization technique, which is generalized reduced gradient non-linear solver method. So after applying that technique, we have another schedule. And this schedule, we have if we can look at our first hour of the day, there were some loads that are being utilized at the first hour of the day. But in this one, it have been shifted to different points, like 21st hour of the day. And in this one, it is transferred to the 9th hour of the day and 13th hour of the day, which will be like at 1 or 2 hour of the day in the previous one. Similarly, in fully shiftable loads, we have reduced the number of loads that are being switched to the different hours of the day. So we can reduce the maximum point at every hour. So as you can see in the last one, which was given by the our customer, we had 5,350 or 70 something watts at the first hour of the day. But applying this technique, we got 2,050 watts at the first hour of the day. Similarly, in the second one, it was very low, around 500 something, but now it have been changed to 2,850 watts at the second hour of the day. So it will be reduced similarly and have been changed from like very minimum to a medium one and very high to a medium one also. So these are the graphs that we have discussed before. These are after applying the technique. So as you can see that the highest value is reduced from 5,700 to 2,800 something, as you can see in this video. So the idea to do this thing is that we need to reduce the variation between the higher value and the lower value. And after applying this technique, we are able to achieve this one. So if coming back to those factors, as I told you before, that average demand and units will remain the same. It is already the same as the previous, but the load factor is improved. It becomes 0.54, which is almost double than the previous one. And the maximum demand have been reduced down to 2,850. So how it is improved? Because we have reduced the variation between the maximum and the lower point, so it have been improved. And improving this load factor means we have improved the utilization of our energy. So the losses in our energy system is reduced and we are utilizing our proper power in a proper way. So this is the comparison of the older one that a consumer was using, and this one, the red one, shows the graph which we have produced after applying our application technique and scheduling load in a different time frame. So as you can see, the highest values is going to around 5,750, but in this one it goes like 2,850. So the variation also, you can see the variation in the new one is very low, but in the first one the variation was very high. So at the peak point, it is around 5,000 something, but here the peak point is 2,800. And the minimum one, as you can see, is like very less. It's close to zero. So looking in this, we can perfectly say that by applying this generalized reduced gradient method on a specific load profile with specific characters, we can improve our load factor. And by improving the load factor, our system can be an optimal solution to utilize our energy in a better, proper way. So as from the results that we have seen, we can say in a conclusion that our main goal was to design a system that can prevent energy loss and utilize the power supplied in a best possible way. In other words, we have to maximize our objective function, which was load factor, and it has been done perfectly, and around uh, twice a double of load factor have been gained from the previous one. Energy supplies from power station is not utilized in the best possible way due to regular schedule of running loads at inappropriate time periods. In this research, an easy and compact way to consume and schedule energy in a residential building have been achieved by following the system. During the whole process, the demand of energy and runtime of load have been kept constant and just schedules as per need of the customer. By results, we can verify that load factor is improved drastically by applying this technique, which was generalized reduced gradient non-linear solver method. And the design system is simulated by using Microsoft Excel solver. This system will be used in home-based energy management systems and industrial load scheduling. These are some references from where I have collected some data to assemble all these situations. And I have applied the technique by taking some help from these references. In the end, I want to thank you everyone for listening to me this carefully. I hope this video will bring some knowledge to your brain about the home energy management system, and you will get some benefit from this video. Thank you very much for your attention. Have a nice day.